Hello, AP statistic lovers. All right, Kitty Morgan here. We're back on page 27 of the student pack, and we're going to go back to some data we've already looked at, and that's the Babe Ruth Roger Maris data. And in our instructions for this example, it says to create a box plot for both players on the same scale, and this is called a side-by-side box plot. I think we've already done this, but that's fine. We can do it again, right? Our whole thing is to kind of look for those little outliers now that we know how to find them and whatever. So here's what I'd like for you to do. I'd like for you to stop the video and input your list, and then I'd like for you to draw the box plots, and then let's talk about how we can most efficiently grab the data from the box plots, okay? So again, you're going to put your list in and draw your box plots. All right, when you come back, we'll take a look at that. So we're back and we're looking at the stat plot data screen. So I've done second y equals, which is stat plot, because I need to make sure that I turn on the right stat plot. So I've got Babe Ruth in L1, I've got Roger Maris in L2. So notice I have on, but look at the types that we have. There are different types. And this one that I have highlighted has these little dots out beside it, and that means they will actually show outliers, and that's what I want. I want to see the outliers. So make sure you check that one. The next one, this one right here, will not show the outliers, and I kind of need to know that. So I'm just going to use the capability of my technology. So when I hit graph, here are my two box plots of this. So in order to find out all the values that I need to know, I'm going to go trace, hit trace. And it is on the blue one, so that is the Babe Ruth one. So I'm going to write down the information onto my paper. I know you can't see that, but that's okay. And so I have all the information here. So the men is 22. So I'm going to write 22 down for my men. And then I'm going to arrow over to the right, and that gives me my Q1, and it even says it at the bottom. See, it says it right there. Q1 is 35, so I'm going to write that down. So I don't even have to do my 5-number summary that I normally go do because it's within the box plot. And then I'm going to go right again, and that'll give me my median, which is 46. And then I'm going to go right again, and that'll give me my Q3, which is 54. And then I'm going to go again, and that will give me my max, which is 60. To find the IQR, I need to subtract 54 from 35, and that'll be your IQR. Let's see, almost, that's, did I say that right? Q3, so it's almost 20, so it's 19. I don't think I did that right. I did. All right, and then outliers, because there's no dots hanging outside the box, I know there's no outliers, we can go do the Q1 minus the IQR and the Q1 plus the IQR. We might do that in a minute just to double check, but if there were outliers, you would see them on this particular box plot. So we're going to go down, and we're going to go over, and then, so I know my min is 8. I'm going to arrow over. My Q1 is 13. My median is 21. My Q3 is 29. My max is not that. That's not my max, but that's the last point I'm going to draw on my box plot. So I'm going to make a little note of that. Let me note that 33 is the end of my whisker, because I'm going to need that when I draw. And my max is actually over here that looks like an outlier to me, and that's 61. And I believe that is an outlier. Okay? All right, so now I want you to stop and draw your box plots. How do you know where the numbers are? Well, y'all, you just found them, right? We went over, and so you should kind of put a dot on 8, a dot on 13, as close as you can. I know it's not perfect. I did mine by 10s, I believe. I did my my horizontal axis by 10s. And remember, it's not ever going to be perfect. So you kind of, where would you put 13? We'll go between 10 and 20. Half of that would be 15. A little less than that would be 13. You just got to guess it, right? So that's how you get those numbers on your box plot. Your median is 21, and make sure you put a box around Q1 to Q3, including that median. All right, so I'm going to give you some time. I'm going to stop and let you do that, and then we're going to go look at our pictures. All right, so we're back, and we've drawn our graphs and our data displays. And I've gone and figured out my outliers. And remember, it's Q1 minus 1.5 times your IQR and Q3 plus. So you're going from the Q1, you're going out, right? So you got to subtract. And then from Q3, you're going out that way. So you got to add the 1.5 times IQR. And so notice that the only one I was really worried about was this little guy right here, right? We saw him way over there. And so I really am only concerned about this guy. And it was 53, and 61 is greater than 53. So we do have an outlier at 61. Okay, so that is the comparative box plot. Now, here comes the fun part. So now we know all these things that we can find out about the data. And the next big question is people will ask you to describe the data. And so in order to describe the data, we're going to put all the different things that we've talked about together. Okay? So let's look at those things. And they have an acronym for them. Well, they actually have 3 acronyms for them. Okay. See if this will focus for me. There it is. All right. So there are 3 acronyms for describing data, and they all talk about the same stuff. They just put them in different orders. So one of them is called cussing the data, and that stands for center, unusual, which is your outliers, gaps, or clusters, shape, and spread. And then SOX is another one I've seen used, and that's shape, outliers, center, and spread. See, so it's the same thing as the cuss is, it's just in a different order. And then the one that Statsmetric uses all the time is SOC-V, where they change, instead of saying the word spread, they say the word variability. So that's your difference. And the big thing about when you describe data, you must do it with the context of the problem, because like in the Babe Ruth, Roger Maris thing, when we're talking about them, they're talking about their home runs. So when we describe the data, we have to talk about in the data distribution of the home runs, here's what's happening. And then we have to include these 4 things, okay? All right, so I'm going to describe Babe Ruth's distribution real quickly with you. They did not ask you to do this in this problem, but you're going to be asked to do this in just a little bit. So I kind of wanted to talk to you about how you might think about this before you got to it. So the distribution of Babe Ruth's home runs, so that's the context that we're talking about, is fairly symmetrical. Now, how do I know that? Well, back in the day, on day 5, and we'll show you this so you remember, we looked at the home runs. Remember this? Yeah, we did this. We kind of analyzed it. And we said it's fairly symmetrical. Not perfect, like there's 2 and 2 and there's 3 and 0, but it's fairly symmetrical. And I don't know if y'all remember this, but we said that Roger Maris was going to be skewed right because of this outlier, or what we thought might be an outlier right there. That's that data point. Okay, so that's how we know it's fairly symmetrical. Now, you know, in stats, nothing's 100%. It's kind of, sort of, right? So fairly is, or somewhat is a word we use. It has a median of 46 home runs, right? So I put the context in there, and that was the median that we just found, and an IQR of 13. That's your variability. There are no outliers. So let's talk a little bit about what I wrote in describing the data. The distribution of Babe Ruth's home runs. Here is your context. I love pink. This isn't showing up very well, is it? Let me get another color. Let me see if my orange will do it. It may not. Okay, here we go. That's not doing it. Heck, fire. My pens aren't working today, y'all. You know what it may be? It may be that I don't have anything underneath it. Let me grab it. Underneath it. All right. That's better, betcha. This will probably let it write harder. All right. So here's the context, and that's very important. That's your context of your problem. So you've let the reader who's reading your information understand that you know that these are not just random numbers, but what they're talking about. You are fairly symmetrical. That is your shape. That is your shape. With a median, what is the median? Yep, that's your center. That's your center. And I told you how many with context. And an IQR, that's your variability or your spread. However you want to think about that. And there are no outliers, and that's the outlier, or if your teacher's using cuss, that's your unusual points. So we have told you all 4 parts with context. So we've told you what we're looking at, what the shape is, what the center is, and what the spread is, and if there are any outliers. So could we have used mean and standard deviation for this? Because this is fairly symmetrical, we could use the mean and standard deviation. But because you can always use the median and IQR for any kind of data, this is a great description of this. And we already had that because we already had our box plot. So it's totally fine that we use that. And sometimes you're asked to compare 2 distributions, and that's what we're going to do next. And to do that, you've got to have the same things to compare. So, you know, Roger Maris's is skewed right because of that outlier. So if I'm going to describe 2 different, sorry, I'm trying to get that done. If I'm trying to describe 2 different ones, I can't compare the mean to the median because that just doesn't work. So if one of your data is skewed, then you have to use the median and IQR for both of them to compare them. So here's just a little comparison of these 2. So let's see how we did. The distribution of home runs for Babe Ruth are fairly symmetrical, while the home runs for Roger Maris is skewed to the right. So, did I do context? Yes. And I think I put home runs as one word. I don't know. And kind of left the U out there. So there's your context, right, for both of them. And there's your context. So we have context. We know what this data is representing. The home runs for 2 different people. And you can't see the word context, so let's do that. There we go. Sorry, I'm moving around a lot. All right, so there's your context. And then I say that one is fairly symmetrical while the other is skewed to the right. So that's your shape. So we have the shape. Shape is done. There are no outliers for Babe Ruth home runs, while there is an outlier of 61 home runs for Roger Maris. So I've talked about the outliers. The median of Babe Ruth's home runs is much larger than Roger Maris's. So I'm supposed to be making sentences, so let me put a period there. Larger. You don't have to say much larger, but you can. So you have to use some kind of descriptive word when you talk about your center. So larger. And it's the median because I have to compare the same center on both things. So that's my center. Got one more, my spread and my variability. The variability for Roger Maris's home run is larger than Babe Ruth's home runs. So larger again, and I'm comparing Roger to Babe Ruth. I could say Babe Ruth is smaller. You can do that as well if you'd like to. Let me move that up a little bit. But that's how I chose to do it. So you have to include all 4 things. Okay, so there it is. That's actually SOCV. And I have to include content. And if you compare the 2 and you have all of those things, you will get all of your points for discussing distributions with your AP readers. Because when you do statistics, it's not just about the numbers, it's about what the numbers mean. So I'm going to tell you something that some of you are not going to like and some of you are going to go, that's really cool. So if you look at, let's go back to this box plot. Then I want to kind of make you think about something. So, the whole premise is that that Roger Maris beat Babe Ruth's home run for a season. And so if you look at the data, he didn't do so hot. Look down here. This is Roger Maris's normal home runs thing, and then this fluke happens and he beats him. So statistics is all about you analyzing data and then maybe asking more questions. Like my question would be, what happened the year he did 61 home runs? That's not normal for him. Was there a change in the rules? Was there a strike? What did something else happen? Because that's not normal for him. I mean, Babe Ruth did well consistently, right? This guy didn't so much. This is like a crazy outlier of what his home runs are. So statistics are made so that you ask more questions that you may not answer right then. But anyway, that's going to drive some of you nuts, and then some of y'all are really going to like that. So that's the whole thing about analyzing data. Either you're really satisfied with your results and you make a conclusion and yay you, or you go, ooh, but that makes me wonder about this. So that's the conclusion of chapter 1. And so I hope you've had fun. I have. And chapter 2, here we come, right? All right. Have fun. Bye.